Okay, so this question is the 11th item off of the EMC 2016, and it looks crazy. But really it's just talking about rules of divisibility. We're going to use those rules of divisibility here. The answer, by the way, here, if you're just looking for the answer, is 12B. But let's talk about how we can get to that. Okay? And this one was important to share the multiple choice because there could be a whole bunch of numbers that this number is divisible by, even when you figure out what P and Q have to be. And I'm going to go about figuring out what P and Q are here in terms of solving this problem. Okay. So number 877-530P765Q6 is divisible by both 8 and 11, with P and Q representing digits between 0 and 9. This number is also divisible by which of the following? Now, it helps if we start by understanding what the rules of divisibility are here. Right? So we want divisibility by 8, and we want divisibility by 11. Right? Now, for 8, divisibility for 8 means that the last 3 digits has to be divisible by 8. In other words, 5Q6 is equal to 8 times some number, okay, where n is an integer. Okay, or let's expand this out because 5Q6 is not proper mathematical notation. 500 plus 10Q plus 6 is 8 times the number. Okay. And now, oops, got cords popping in and out here. Now, let's talk about what that means. Right? So 10Q plus 506 is equal to 8 times some number. And if we were to divide through by 8 here, 10 over Q, or 10Q, okay, over 8, plus 506 over 8 is an integer. Okay? I want to focus on this right here. If we take 506 and we divide it by 8, okay, we get a remainder of 2. Okay? Remainder here would be 2, which means that, okay, this tens digit with a units digit of 2 has to be divisible by 8. So something 2 is divisible by 8. And there are only 2 numbers that could be 32 or 72. So we know that Q is 3 or 7. It's one of those two. We're not sure which one. All right, now, the other thing we know here is divisibility by 11. And to be honest, I had to look this one up when I saw this problem for the first time. And it's a really interesting rule of divisibility, and we could prove this. It'd probably take us quite a while. But the divisibility by 11 rule is if you start with the first digit, subtract the second, add the third, subtract the fourth, etc., 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 then you should get a number that is divisible by 11. Okay. So this is equal to 11 times some number, okay, where that number is an integer. Okay. Now, if we total up all those integers, all those whole numbers, okay, we get a negative 6. So this simplifies to P plus Q minus 6 is equal to 11M. And let's simplify that even a little bit farther here, because we now know we have 2 options here for Q. So if Q is equal to 3, then P minus 3, plug in 3 for Q, P minus 3 is a multiple of 11. And the only way that's true is if P minus 3 is either negative 11, 11, or 0. And it really can't even be negative 11. Okay, so the only way, and you're not going to get to positive 11 or to negative 11 since P has to be a single digit number. So this means that P would have to be 3. Okay, or if Q is equal to 7, then you plug in 7 for Q, P plus 1 is equal to 11M. And again, for this to be, you need p plus 1 then to either be 11 or 0 or negative 11, which can't be. Won't get to 0 because that makes p a negative number. And so p would have to be 10. But 10 is 2 digits, so it can't be that one. So q can't be 7, so q has to be 3, and therefore p is 3. Okay. Now at this point, you could plug in, 3 and 3, and you could try the divisibilities. Okay, you just try dividing on your calculator by that, certainly, or dividing by hand if you're a real glutton for punishment. We're really close to some of these though. So for 12, and 7, I'm just going to ignore that. If these others don't work, I'm going to go back to 7, but I'm going to start with 12. For 12, it has to follow the rules of divisibility for 4 and for 3. Right? Well, it certainly follows the rules of divisibility for 4. It's divisible by 8, so therefore it's divisible by 4. And then divisibility by 3, I take the sum of the numbers 8 plus 7 plus 7 plus 5 plus 3 plus 0 plus 3 plus 7 plus 6 plus 5 plus 3 plus 6. I'm just looking for that to be a multiple of 3. Okay, so let's do this really quickly. I'm not even going to find out what this total is. I'm just going to add the multiples of 3. So that makes a multiple of 3. That is already a multiple of 3, multiple of 3, multiple of 3, multiple of 3. I've got 7 and 5, which is 15, and 7 and 5, or no, sorry, it's 12. So that's a multiple of 3, and 7 and 5. Here is 12, which is a multiple of 3. And so this sum is a multiple of 3. And so, yes, that checks out. Works out that 12 is indeed the correct answer. Okay? Now, had it not been the correct answer, then we could go on to 16. And for 16, it's just the last 5 digits has to be divisible by 16, which it's not in this case. 18, it would have to follow the rules for 9 and for 9 and 2, which it is even. And so you'd go back and you add these numbers up and see if they were multiple of 9, or just see if you can come up with, eliminate things that add to 9. Right? Very good.